I've been out there. I've never been in Los Angeles yet, the SQL Saturday, but hopefully maybe next year, visit in person. So today I am going to speak about the new product of Microsoft Azure SQL Edge. And I'm going to try to show you step by step how to install SQL Edge on, really that's going to happen in an IoT device, but on here, I'm going to cover the Raspberry Pi. So before I start though, I'm going to actually cover some other topics. And I think that if you're in IoT, I think that will be useful. We are going to cover the history of IoT. I'm going to try to explain what the IoT is. I'm going to give you some stats and some of the challenges IoT currently has. And then we kind of feel like, I guess, good about what really IoT is and what the potentials of IoT. Then I'm going to introduce you the IoT features of Azure. And from that, we can actually go in and look at the SQL Edge. We are going to look at the Azure IoT Hub, and then we kind of explain all of those, how they work in the back end. Then I'm going to actually show you step by step how to install SQL Edge to Raspberry Pi. And at the end, I'm going to have a demo. I'm going to show you actually connecting to my SQL Edge in my IoT device is currently running right now. So that is the plan. So let me jump in before I go actually start this presentation. Let me speak about myself. My name is Hasan Savran. I am a Microsoft Data Platform MVP. This is my second year. I am from Cleveland, Ohio. And currently I am a business intelligence manager at Progressive Insurance. And I have a good amount of web development and data experience. I have my blog. If you kind of know me, probably you know me mostly for the Cosmos DB. I write a lot about the Cosmos DB. But rather than that, you can find a lot of other stuff in my blog. I have a lot of SQL Server topics, front end, C#. So whatever I know, I like to share in my blog out there. So check it out. You might find something you like. And if you will have any questions about the things that I'm going to cover today, and if I will not have time to answer your questions, you can always reach me from the LinkedIn on Twitter. I will be happy to help you from there. So let's jump in the presentation. So first, I'm going to talk about IoT history. Let's try to understand actually where we are coming from and what was the challenges and where we are right now. So the history always kind of helps with any kind of topics. So really, IoT is really not that new. It came up in 70s and 80s, like many other great things came up from 70s and 80s. And in those days, people came up with the idea, and rather than IoT, they called that connected devices. So the idea was the same. You connect the device, and it tries to kind of give some information and shares it. The problem was, well, the technology was not there. Idea was there, but technology was not. So the chips were pretty expensive, and there was no Wi-Fi, and we have limitations with internet addresses. So all of those things has to be resolved first for actual IoT to happen. So the chips, really, I remember my first computers, it was like 286, 386, they were pretty expensive then. And there was no way you were going to be able to get that CPU and put in a small device and make millions of it. It was going to be very expensive. We had to wait 2010s for those chips to get actually affordable, so we can actually easily put those in devices. The second thing we had to wait was the Wi-Fi. Again, 2010s, I will say it became very common communication. And the last thing we had to wait, which was really the turning point, and it was, I believe it was 2011, the revolution, like it's going from IPv4 to IPv6. Before that, simply we did not have enough IP addresses for IoT devices to actually go like crazy. So we had to wait for that evolution from IPv4 to IPv6, and that was a turning point. So in that point, nothing was stopping the IoT idea. You can have millions, billions of devices, and you will have enough IP addresses to actually put them on online. So if you look at the first IoT device, that is actually the first one in 1982. It was a Coke machine, a vending machine. And it was in one of those actually universities. Students came up with this idea. They put a sensor in this, a computer and a sensor in this, and connected to a network. So what it was really doing was it was just sensing the temperature in it, and it was just sharing. So that was really the first IoT device. Then we had to wait a little bit more to actually come up with this idea, this is John Ronke from 1990. And he actually connected his toaster to internet by using the TCP/IP protocol. That's the first time actually somebody's using TCP/IP protocol to connect the device, in this case as a toaster. And he was very excited here. As you can see here, he was able to just actually keep those breads in the toasting machine X amount of minutes, and he was able to connect that from the internet. So that was 1990. Then we have first camera comes up, first web camera, 1991. Well, not surprisingly, this is another university. I believe this was the University of Cambridge. And scientists, well, they were working very hard, and every time they went back to lab, they see that their coffee machine was empty, and they kind of got tired of it. So what they said, well, let's actually put a camera on here, and they just put the camera out there, connect the camera on the network, and the camera was taking picture maybe like every 30 seconds of the coffee machine. And so whenever the actual coffee went low, they knew that, and they went and make the coffee. So it never kind of, I guess, they were not out of coffee, I guess. So, but that was the idea with the web camera, 1991. Then this complex machine comes up in 2000. This was really a refrigerator, and it had all kind of functions in it. You could watch TV. There was an electronic pen. You can actually write on that screen. You can actually have video messagings and all kind of stuff. So for 2000, it was really complex. The problem with that was, and it was a great idea, but as you can see, the price of it was $20,000, and that's 2000. And that was really the first internet, I guess, connected refrigerator then, but it failed because of its price. So really, if you really think about all the things that I just showed you, what is IoT? IoT is really just a bunch of sensors on a board. And that board is actually get the data, then it just shares. And from that point, really, whatever is getting shared, you can do it, all kind of stuff with it. If we look at the numbers, so if you remember, I was talking about this IPv4 to v6 evolution. That happened in 2011. So you see the number of IoT devices here in period of time. And the number you see out there is right now 50. Actually, that's 50.1. And that's not a million, that's billion devices. That's a crazy number. That, as you can see, after 2011, just IoT went kind of crazy. And there's all kind of devices here. We have the smartphones, we have self-driving cars, we have all kind of sensors really everywhere. And if I try to show you this graph in a little bit indifferent, I think it's going to make probably more sense. This is the population against the IoT population. And as you can see, in 2020, we have 7.6 billion people on Earth, but we have 50 billion IoT devices. That almost makes 6.58 per person. Well, it makes 6.58 person, but that really number is kind of like lying here because, yeah, this is the math. But the problem is we know that not everybody has internet, and not everybody is, as a first world country out there. So many people does not even have the internet or the technology. So that number out there, 6.58, probably much higher than that if we are just talking about actually who has the internet. So if you look at, I guess, the devices, what kind of devices are out there? So the most, I guess, the popular one that I can say is the smartphone. Smartphone is the IoT device. It has all kind of sensors on it. It can figure out what's your heartbeat. It can figure out how fast you are going and all kind of stuff in it. And it shares, do you like it or not anyway. But in here you can see, there are many other applications here. So if you are going to work in any of those, if you want to work in the IoT, I guess, business, your application is going to be probably one of those in here, and it needs to kind of, run any of those devices here. Those are mostly for, like a small applications. If you are looking more like a large scale IoT stuff, as you can see here, we have some different things here. The biggest one here is, you can see, is a smart city. So if you have in one of those big cities, really all the traffic and everything is actually getting controlled by the computers. So the computers has the screens, they watch the traffic lights, and it knows that how bad the traffic is, and they kind of control the lights. Another idea here is we have connected cars. They share all kind of data out there, and they need to process the data very fast. So there are a lot of things going on here. So really, if you are going to work in any of those large scale users, those probably is going to be one of the big ones, the list one in here. The first thing you need to worry about in IoT devices is really the connections. When it comes to connections, we have really three options. If you talk about the perfect connection, I will probably say that, it will consume probably extremely little power. It will have a huge range, and it will have to transmit large amount of data with all those options. The problem is that it doesn't exist. So we have three options here. The first one is it needs a high power, it needs a high range, and it needs a high bandwidth. So that really explains us the cell phone. If you are going to go with this connection, your connection is going to be expensive because, the cell phone is going to be the most expensive option for you. But in the meantime, you can actually, really reach anywhere on the earth, and you can really send data very fast. The second option here is it needs low power, it's low range, and it has a high bandwidth. So that really is the Wi-Fi or the Bluetooth. Probably that's the best one in here. It's much more affordable than cell phone. And all you have to do is, you kind of need to put a router wherever your devices are. And as long as they are in the range, it doesn't really take that much power to use it, and it has a high bandwidth. So probably that's the most common one. The last one here is the low power wide area network. I really didn't know about that much. I really learned when I was actually kind of working with some of the IoT devices. So this is mostly for the best I can give you is really the agricultural sensors. For example, you might have a sensor on like one field, maybe it's just checking the soil's temperature. That data doesn't really change that much. And by using the LPWAN, you can actually use really low power, and the range is pretty high. We are talking probably like 2-3 miles, and the low bandwidth because your data is really not that large. All you are trying to share is just the temperature of the soil, maybe every, 1 hour or something like that. So those are the options when it comes to the connections. The second thing you need to worry about IoT devices is the security. Security is a big issue in IoT devices. And the main reason for that is, the device is not really that powerful. So it's much easier for developers to just hardcode the connection string or whatever it's trying to do out there and just forget about it. If you think about it, if your company is going to have like 1 million IoT devices, it's really not easy to go and change the password, right? And mostly the IoT devices might be really sending simple data to, right? If you are sending the temperature, if you're sending the other, like really simple data, people really don't worry about it that much. And the other challenge is, as I said before, the device is really not that strong to actually support any kind of advanced security features like encryption. So those are the two big issues. And if you really think about what this might mean is actually, you might see that in the TV just happened. So hackers were actually able to close some of the pipelines of the United States, and people were out of oil. So how did they even do that? We don't know exactly how they do that, but we know one thing is the pumps and everything is all of those IoT devices, right? So as long as you are able to connect to their network and go in the network, you might have, if you don't have the IoT devices great, security, you might be able to connect and do all kind of crazy stuff like that. And that's a kind of great option, I guess, great example how the IoT devices really can affect everyday life very easily. So now I think we are in good place to explain what options we have when it comes to the Azure. So Azure has this product named Azure IoT Hub. And Azure IoT Hub is really the central place that all of your IoT devices are going to connect and send and receive data. So that's really the hub group. This is the place that you can actually send information back to your devices. So you don't really need to know their addresses and other stuff. Azure IoT Hub is responsible for that. And it's reliable. And it actually, Azure IoT Hub brings some kind of security on the table because your device has to be able to connect to Azure, and Azure has its own kind of standards for that. It is very scalable. So if you have 100 devices today, and if you're going to have 1 million in 5 years, Azure IoT Hub really does not really care about the number of the devices. It can support that, and you can actually go up and down very easily with that. When it comes to the scaling, the only thing you really need to know is this is the prices. As you can see, there are two things you need to look at. The first thing is the number of devices you are going to have, and the second thing is how big is the document you are trying to send. So all of the things that I actually did in this presentation, I use the free one. As you can see, I can send 8,000 messages per day and 0.5 kilobyte of document. So that works for me, and that's free. But as you can see, that's how you are going to be able to scale up and scale down. Depends on the number of your devices and the size of your document. But IoT Hub is really the entrance, right? After you are able to send the data, you have many options because Azure is a great, has great features to do many other things. So you can really create pipelines to many other features. Those are the main ones I just listed here. Like, for example, you have Event Grid. It enables your business to react quickly to critical events. So you can create a pipeline with the Event Grid, and well, you can do something about whatever you just received. Logic Apps is really for automating the business processes. You can do any kind of like machine learning by just adding the AI models. Or you can have the stream analytics. That's for mostly to run like real-time analytics computations, which whatever is coming from the IoT Hub. So you have great options with Azure if you are going to use Azure IoT Hub. We have another, feature or option is Azure IoT Hub Edge. So when we really talk about edge computing, what we are really saying is, rather than we want to send every messages to Azure IoT Hub and maybe wait for a response, we are actually giving more responsibility to our device. So if, for example, we are out of networks and we cannot connect to Azure IoT Hub, in that case, our device might be able to maybe store that data until we have back the network so we won't lose the data. Or we can actually put an AI kind of like a modeling in our device, and it can actually handle things rather than try to call Azure IoT Hub and wait for the response. So it's more reliable, and everything is working with the containers. So all the applications that you want to run in your IoT device, those has to be in container, and you have to send them from the IoT Hub. And IoT Hub Edge is going to actually send all of them to your devices, and they are going to be able to run those containers in the devices. That means you are going to have less network calls because your device can handle more rather than calling Azure IoT Hub for everything. So I think we are in good shape to introduce Azure SQL Edge now. What is Azure SQL Edge? Currently, it is the SQL Server 2019 version on Linux. And Microsoft recommends you to have Ubuntu 18.04 as the operation system in your IoT device. And it's only the database engine. But still, it's not 100% of the database engine. So it doesn't, for example, support many things like, for example, file tables. I don't think it supports in-memory tables. So really, it's not like 100%. There are a couple of things that is not, it doesn't have. Also, it does not like have any kind of SSIS or any kind of reporting services. So really, this version doesn't need any of those. Or in the meantime, even you have it, probably you're not going to be able to run that in that small IoT device anyway. Also, architecture-wise, you are going to need a 64-bit processor. It can be x64 or ARM64. That's where actually Microsoft introduced this idea that you can install the SQL Server in IoT devices because most of them has the ARM64 architecture. You need at least one CPU and 1 gig RAM. Can you hear me now?
Yes.
All right, because I thought I was, it looks like I was muted. So what happens here is as soon as Azure SQL Edge starts, the memory footprint is actually the 450 megabytes. So depending what you are trying to do with the SQL Edge, you might need much more than 1 gig RAM. And that really depends what you need to do with it. A couple of other things I'm going to cover here is in this version, you have some features that many other SQL Server versions does not have. For example, you have the SQL streaming. SQL streaming is based on the same engine that powers the Azure Stream Analytics, and it provides real-time data streaming capabilities in Azure SQL Edge. We have a date bucket T-SQL function, and that's really most for the time series data analytics you can use. And also it supports Onyx runtime. That's mostly for the machine learning capabilities. Pricing-wise, as you can see, you can go as pay as you go. That's, well, let's say $10 per device per month. If you want to do it reserved, then you can have option for $100 or $60 per device and per year. When you look at those numbers, really, they are pretty cheap if you compare to regular licensing or enterprise licensing. But don't forget, this is a price per device. So if you have a 1 million IoT devices, that's going to be a pretty high number. So IoT devices are really like babies. They cry. So babies cry to communicate. IoT devices send constantly data to the Azure IoT Hub. And that becomes really the big data because, well, depending how many IoT devices you have, you might be getting like millions or billions of numbers of documents per, I don't know, 30 seconds, 20 seconds. That depends on your business. So really, what SQL Edge actually does here is it works just like a pacifier. And when you give a pacifier to a baby, it kind of gives you a little bit, I guess, peace. You can maybe drink your coffee or you can have some peace. And baby actually is fine. In here, the IoT device is the same way. We have kind of two pacifiers we can actually use in IoT devices. And our IoT device can actually save the data in our Azure SQL Edge tables rather than sending the data constantly to communicate. And that will actually give you more peace because whenever the network goes down, that doesn't mean that your IoT devices kind of stop working. In this case, you might be still saving them in your tables in the SQL Edge. As I said before, we have two versions. The first one is for developers, and it supports 32 gig RAM and 4 cores. And the production version it supports 64 gig memory and 8 core CPU. So how does it do it? To do that, first of all, we have to install the runtime to our IoT devices. The runtime really turns your device that is, complicated with the Azure IoT Hub. What actually it does is, in this way, you can maybe send the containers from the Azure IoT Hub to your device, and runtime actually manages that. If it needs to download any kind of containers, it does. If you push any kind of configuration, it changes the configuration for you. It sends all the reports, report the module health. If something is going wrong with the application or your device, it just sends back to IoT Hub. It manages all the communication for you, and all the security standards is actually in this runtime. So it's pretty important component, and you have to install that in each IoT devices that you want to connect to Azure IoT Hub. To do that, there are actually two modules running in the runtime. The first one is the IOTEDGE agent, and that's really mostly for installing the modules. In this case, like SQL Edge is one module, and it just reports all the status. So as you can see, those are the statuses actually it can send back to IoT Hub. The second module is the IoTEDGE Hub, and it really works as a local proxy. So it doesn't have to call the IoTEDGE Hub for every messages. So this one actually works as a local proxy, and it sends the reporting status and communicates all the stuff with the cloud in the backend for us. So that was the, I guess, SQL Edge information. So let me actually move to my Raspberry Pi. When I bought my Raspberry Pi, I think it was maybe 2 years ago, and that's what it came up with. And it's pretty amazing what it can really do. So here is it's kind of, I guess, the features. So it has a CPU. Mine was 4 gig RAM. It has Wi-Fi, which supports 2.4 and 5 gigahertz. And we have Ethernet ports. We have USB ports. We have 2 HDMI ports. Believe it or not, you can connect two monitors on that thing. And it supports the display port, camera port. As you can see, it's amazing. And this device was like all the stuff you see here. I think it was less than $100. So I got that. And the problem with that was the operation system was Debian Linux 10. And, well, Microsoft supports or suggests Ubuntu. So I had some problems with that, which I'm going to share with you. So whenever you are buying the Raspberry Pi, just if you have an option, just try to get to Ubuntu rather than Debian or anything else if you want to actually use the SQL Edge on it. Now, I think I have my device. I'm really not a Linux person, so I do everything in Windows. So I did not want to just connect, I guess, or give one of my monitors here to that device. So I want to make this, I want to be able to remote in and do everything like that rather than just vesting one of my monitors on it. So to do that, we are going to need to open SSH to actually communicate and remote into the device. So to install that in Windows, actually you can do that by the PowerShell. To do that, here's the commands that I ran. As you can see, I just in the PowerShell, I use the Windows capability, and believe it or not, there's an actual client for OpenSSH and client and the server for the OpenSSH. As you can see, I am just adding that to my Windows. You don't need the server. I'm just kind of showing that it's available here. And after that, I have to kind of configure that. As you can see, I am starting the SSHD. And from that moment, I am just checking the service and being sure that it's running automatically every time I start up the machine. And the third one is optional. Get net firewall rule. You want to be sure that it's not going to be behind the firewall. So this one actually gives you all the information and looks like it's not behind the firewall. So you might have some problems if you try to control or if you try to remote into the device. So those are the things that I did. Or rather than doing that, you might use any of those third-party tools to actually remote in if you like. But this one is free and this one is Windows. And it was pretty easy to configure that for me. So that was my first step, to be able to actually log in to my Raspberry Pi or any other IoT devices which has a Linux operation system. As you can see, all I had to do is SSH, Pi is my username, and I give my IP addresses. It's going to ask you the password. If the password is good, I'm in my Raspberry Pi, and everything from that moment is going to be, run in Raspberry Pi. Now, before I go in details about what to download for this, I want to actually talk about one more thing, which is the CPU architecture, because there are a lot of things going on in Linux. Whenever you try to download something, you will have the same file, but in many different architectures, CPU architectures. So this is the same thing if you had 32-bit and 64-bit application. So your 32-bit computer cannot run the 64-bit application. Same with the Linux, but now we are actually introducing the ARM32 and ARM64 on top of that. So whenever you are downloading something, you want to be sure that whatever chip you have in your IoT device is matching to the whatever you are installing. Because if it doesn't, it's not going to tell you that, oh, you know what, this application is for, I don't know, 32-bit, but you have ARM 64-bit. The error you are going to get is not going to be friendly like that, and the error is going to make absolutely no sense. I'm telling you because I was in that situation, and it took like at least 1 or 2 days for me to figure that out, because I was trying to find what is really the problem is. And at the end, I figured out that I downloaded the wrong file. So just an FYI. Also, I did not know one more thing, which is Azure IoT Edge has different supporting systems. So as I said before, Microsoft suggests that you should have the Ubuntu. I had Debian. And problem is, the Debian was not really supported by Microsoft. So there are some kind of 2 different tiers here, which I'm going to cover in a little bit here. Also, you want to be kind of a little bit friendly with the containers, because you want to be able to run the containers manually. You might need to list them, be sure everything is running. So you want to be sure that you have some knowledge about the containers too before we continue. Now, when it comes to the supporting systems, there are 2 tiers when it comes to the supporting system. Tier 1, if your operation system is one of those, you're lucky. That means that Microsoft supports them. And also it gives you all kind of guidelines, all kind of scripts, all kind of repositories. So really, to install the runtime to your IoT device might take 2, 3, maybe 4 syntaxes, and you are done. That's why we have Ubuntu Server 1804 here, but you don't see the Debian here. So when I see that, I say, OK, I'm going to go and actually download the Ubuntu and start from the scratch. Which I did that, but I guess I didn't pick the 1804. I say, when I look at the Ubuntu, the latest version then was, I think, 2004. And I was like, why should I just download the 1804 when 2004 is out there, right? So I downloaded 2004. But when I came back here, well, 2004 is not here. 2004 is in the tier 2 support. What Microsoft is really saying by the tier 2 here is, well, if your operation system is in this list, yes, it will work, but you are on your own to make it work. There's not that much scripts. There's not that much repositories out there. There's not that much guidelines out there. So that's a challenge, especially if you are new to the Linux. Now, I'm going to actually show you step by step how I did this. And first, I'm going to show you tier 1, and I'm going to show you the tier 2. So tier 1 is the easy one. The first thing you have to do is you have to go to the packages, Microsoft.com config, and find your operation system. So in this case, for example, you can go to 1604 and download the prod.list file by using the CURL syntax. CURL stands for client URL, and what really I'm doing here is I'm downloading this prod.list file from the Microsoft website, and I'm putting in my local folder as Microsoft prod list. Then I need to register this, but this prod list is really the repository of files that you need. So you kind of need to register this repository to Linux, and then whenever you try to write the syntax, Linux will know where to get those files from. And the second one, that's what I'm doing really. I'm just taking the sources, that Microsoft prod list, and I'm putting under the sources list D, which is the repository of Linux. And whenever you try to run something, it's going to look at there. In this case, if you have a Ubuntu server 1604, it's going to find it, and it's going to actually download and run everything automatically for you. So this is the first step that you have to do for tier 1, if you are in the tier 1. The second one is for the PGP. That's mostly for the Azure's security, and you need to download the key from this location. I still use the CURL here, and all I'm doing is I'm just downloading that file and saving it as Microsoft GPG file. Then I am actually registering it by copying it to this folder, trusted gpg.d folder. So that's all I'm really doing. That applies to tier 1 or tier 2. So it doesn't matter which tier you are in, you must have to do this. One, as I said before, we need the containers, and everything is in containers. SQL Edge actually comes as a container. So we need a container engine. And for container engine, Microsoft actually uses the Moby engine here. And you need to install the Moby engine to your device. So this one applies to tier 1 and tier 2. All I'm doing here is I'm just installing the Moby engine, and then I'm just configuring it by the last syntax you see here. I'm just downloading the file, and I'm just moving it and running the configuration. So it configures my container engine in my device. And this one applies to tier 1 or tier 2. Now, from this moment, I am kind of ready to install my runtime, IOTEDGE runtime. This will work only for tier 1 because, as I said before, in here, this file here, that prod.list, actually knows where the IOTEDGE file is. I'm just trying to install IOTEDGE. And if you have Ubuntu 1604, 1804, this is going to run with no problem, and you are going to be happy. If you are looking for a specific version of IOTEDGE, you can even specify that by using those two, the last two comments here. If you are in my case, which is 2004, and if you try to run apt-get install IOTEDGE, it's going to say, I have absolutely no idea what IOTEDGE is. That means I need to go and actually find it myself. So from this moment, I'm going to actually, everything we are going to see is going to apply to tier 2 operation systems. The first thing I have to figure out is, well, what is the dependencies of IOTEDGE? There is one dependency that actually breaks all this things that I just showed you from 1804 to 2004. What that is really the SSL. So what Linux did was they upgraded their SSL reference file from, I believe, 1.0.0 to 1.1 or something like that. And that broke the IOTEDGE because IOTEDGE requires libSSL 1.0.0. So really, basically, you have to go and find this file first and download it. As you can see, when I try to download it, this is the same file, but there's like 2, 4, 6, 7, 8 versions of it. Really, each version is different because architecture, CPU architecture is different. So you want to be sure this is the place that I made the big mistake and I picked the wrong one, and it just didn't want to run because the CPU was wrong. So in here, as you can see, The right one for mine, a Raspberry Pi, was the Ubuntu ARM 64. I had the 64-bit CPU, ARM 64-bit. So to download that, I'm just going to use the C URL and just download this file. I'm just downloading from this location and putting in the test.deb file. DB is really for almost like zip files, but you have to kind of depackage that after you download it. In my next one here, as you can see, let's see, I am running here. Sudo is really the do as super user. I guess you can say that run as admin in Windows. And I am depackaging this file, and as you can see, it gets all the files, and from there it just installs whatever's in it. In this case, I am installing this 1.0.0 SSL file, so the IOTEDGE will actually run. So after this, I need to go and actually find the IOTEDGE wherever it is. Since I don't have the repository files that Microsoft actually supports, I have absolutely no idea. So I had to go and find that. Actually, Azure IOTEDGE is in GitHub. So you can actually go and download any releases here. When I did this, this was the latest version then. So I downloaded that. And after you download it, I use the C URL. Again, put the URL out there. It will download it. And from there, you can install the IOTEDGE. As long as you are good with the libSSL 1.0.0, your IOTEDGE should not give you any problems when it tries to install. As you can see, after I download it, I install it, and then I start to say that, okay, this is the Azure IOTEDGE. I'm trying to install this to your system. And as long as you see this, I guess, syntax, we are in good shape. Now, from here, everything should just go fine. And the next step for you is going to be actually enabling your device to, or registering your device to Azure IoT. There are 3 ways to do this. And I'm going to show you how you do it in the Azure portal. But you can do it by the VS Code by using the IoT Tools extension, or Azure CLI. You need the IoT extension for that too. So I'm going to show you how to do that by the Azure portal. Before I show you that though, there are one decisions that we kind of need to make, which is how the connection is going to actually happen. You have 2 options. It can be a symmetric key. This is like almost a connection key. You just put in your web config. It's just some kind of token. Or second one is the more like certification. Is mostly if you are going to go production, probably that's the way that you want to do with the X509 certification authentication. Which way doesn't really matter which way you're going to pick. You still need to go to the config file and actually put this information in your config file. So let's actually register a device first. So to do that, you have to go and create an Azure IoT Hub. Pretty easy. All you have to do is really a unique name for your Azure IoT Hub. And from there, you're going to maybe probably wait 1 or 2 minutes, and everything is going to come up. Then you're going to actually start to add your IoT devices in your Azure IoT Hub. To do that, you are just going to click this button here to add IOTEDGE device. Then window is going to just come back from the right side. And you are going to, as you can see, what's the authentication type? I'm picking this symmetric key here because this is much easier. And that's going to give me a primary key and secondary key that I'm going to actually take from here and put in my device. Rather than those, it's really not asking that much here. You're just going to click the OK here, and that's going to be it. This is just going to create the device in your IoT Hub. When it's created, you are going to actually go and click on it. As you can see, I name it as RASP4. I have a primary key here, a secondary key here. This is my connection string. So I'm going to actually copy it here from here and just paste it in my Linux runtime, the one that I'm just downloading. So to do that, when the installation is actually done, the one that I was showing you for the IoT Edge, you need to go to the config file, which is named config.yaml. And as you can see, you want to run with this sudo because, well, if you're going to change anything, you want to run as an admin. And nano is really the notepad of Linux. And all I'm doing here is just open this file in Notepad Linux. And you need to go and find the section and just paste the connection string that you got from the Azure IoT Hub in here and save the file. Then you are ready to actually restart your IoT Edge runtime application by running this syntax. And from here, you can actually check the status. And when you run the status IoT Edge by the system control, you are going to actually see this page. Hopefully for you, everything is going to be green. And I don't have any problem with that if the IoT Edge runtime ran fine. You should not have any problem with that. But all this thing is really doing is it's using your connection string you just put there. It's trying to connect to the Azure IoT Hub. If everything is green here, then that means your device handshake with IoT Hub perfectly, and it's ready to actually send data or do something. So that means you are in good shape. And from really here, we are ready to push any kind of application into our IoT device. So as you can see, I mean, so far, we have to configure our IoT Hub. We have to download all kind of application just to be sure that you have the right architecture and other stuff. We haven't even touched the SQL Edge, really. All we were just trying to do is just prepare our IoT Hub so it can actually connect to Azure. From this moment, everything I'm going to actually show you is going to be above the SQL Edge. So I showed this screen before, and we got our connection string from here. So we have to go back to Azure IoT Hub and open our device, which is the REST 4. Now, actually, I know that my device is connecting to Azure IoT Hub. I can actually set modules. So that means I'm going to send some modules to my device from the Azure IoT Hub. So I'm clicking on this button here. Then there are many ways that you can actually have your own custom containers. If you're a developer, you can write your own kind of application and send it. Or you can, in this case, we are going to use the marketplace module because the module we are going to try to send is a SQL Edge. So in here, I'm just clicking the add, and I'm picking the marketplace module. Then I'm just searching by SQL. As you can see, we have Azure SQL Edge Developer. I'm going to pick that and just really click OK from here. And it's going to ask me if you are familiar with the containers. This might look familiar too. So you kind of need to give some information to the SQL Edge. So after it's installed and ready to run, you can connect it by giving you the SA password. You can need to accept the URL. You have to put all of those as the yes. And you can actually change all kind of other information here if you like. So what's really happening here is you are just giving this configuration, and IoT Hub is going to send this configuration back to your device. Your runtime is going to receive it. And well, first time you're not going to have this. So it's going to take some time for IoT, your runtime to actually download this. And then it's going to start to run the container with the configuration you just give here. Then from that moment, you should be able to connect your SQL Edge from your device. So that's the workflow, how it's going to work. So to actually check the status of this, as soon as you click the send here, probably you need to kind of wait depending how much, how fast your device is, the network connection is. You are going to actually use this syntax IoT Edge list, which is going to list all the containers running in your IoT device. And as you can see, Edge Hub and Edge Agent, they should be up and running because they are controlling all the IoT Hub network connections. But as you can see, I have the Azure SQL Edge here, and it's running. So that's where it's actually coming from. If you see that, then that means you are ready to actually connect to Azure SQL Edge. So in here, I guess let's try to connect my SQL Edge in my IoT Hub. So to do that, let me go, and I'm going to use the SSMS here, but you can really use any kind of client for the SQL Server. So I'm going to go here. I'm going to go connect my database engine. This is my current IP address. This is the login and password that I just actually write in IoT Hub. And from here, I'm going to click connect. As you can see, I am connected. I create one database named sensors. So really, from this case, everything is really working just like the SQL Server. As you can see, you have tables. It even supports the graph tables. And I can just create a table. Let's say we have a, I don't know, oxygen sensor, right? So let's say, I don't know, sensor, and maybe it's sending us, I don't know, integer and OT value. And we can make that. So when I run this, this is going to run. Actually, this is running my IoT device. I just create a table. And as you can see, it's here. So from this moment, what I can really do with SQL Edge is developers can create any kind of applications which can actually get all this sensors information and maybe push in this table. And you can configure SQL Edge to actually send them to Azure IoT Hub immediately, or you can configure all kind of stuff here. You can push here the AI models, and you can decide when data comes in. You can do all kind of stuff here. So I'm not gonna have time to show you all those things. But as you can see, right now I'm running this in my Raspberry Pi, and I'm able to connect to my SQL Edge, and I'm able to create tables. From there, really, you can do all kind of other stuff. All right, so I think timing-wise, we did good. That was my actual last slide. And thank you for listening to me today. Thank you for coming to my session. And hopefully you learned something new. And any questions I can answer now, or you can reach me from any of those platforms. I will be happy to answer any of your questions now if you have. Thank you.
Thank you for your presentation. I'm trying to see if there are any questions. It doesn't look like it. I'm wondering if it makes sense at this point, given it's the end of the day, to just go ahead and unmute everybody and see if anyone wants to speak up and, just ask their question if people don't feel like typing.
Sure.
I guess this is an experiment. Here we go. I'm going to unmute everyone. Don't all yell at once. Oh, can't do it. Darn.
So I got one question here from Raymond. So really, I guess next thing to do here, which I guess my next presentation is going to be about, but probably that's going to be mostly for the developers. I want to actually create a very simple C#.NET core application and make this in container, and probably buy a bunch of sensors. It can be oxygen sensor, I don't know, any kind of sensors. Try to read that data and put that in the database, SQL Edge. So in my case, it's just an experience for me. So really, I'm not sure what my sensors are going to get, but really all I'm going to do is get some data, and let's see what else I can do with that data. I want to try to maybe send it to Azure IoT Hub and maybe just block the network. Let's see what's going to actually happen in the IoT Hub. How is it going to, handle it? So those are going to be kind of like my next steps. But mostly, if with the IoT devices, really, depending what type of business you have, you might have IoT devices. If you have like planes, you just put them on your engines. They are just watching the, I don't know, the oil. It gets all kind of data. And if you are like on a plane, you're on ocean, you might not have a connection. You just save that data And when it comes back to the port, you just download it to IoT Hub. So there are some, ways to use it for sure. As I said before, there's like 50 billion IoT devices out there, and there's a huge potential out there, because if Microsoft can actually install the SQL Edge 1% of that, that's a huge number of IoT. That's a huge marketplace. So I'm sure there's many opportunities out there.
Looks like we have another question.
Okay.
It says, as compared to Azure SQL, are there any limitations of IoT Edge?
Yeah, I mean, there are many limitations when if you compare to any other versions of SQL Server, because Azure SQL is just like real database. It has the power, right? You are limited with the IoT device power here, so the things that you're gonna do is not gonna be that complex, and there are many limitations. As I said before, we are really just talking about database engine here, all the kind of reporting, analyzing, and all kind of stuff. You don't want to do those in your IoT device anyway. So yeah, there are many limitations out there when it comes to the IoT. And the other thing, usually I get a question, like, because people likes the price of IoT Edge version. And then they started thinking like, oh, you know what, maybe we can put our, SQL server out there, SQL Edge, and maybe do other things that, might costly if you want to do in the other versions. Whatever you are trying to do with the IoT Edge version, it has to be about IoT. So if you try to do something else, then you might have trouble. You might have problems.
All right, looks like we don't have any other questions. I'll ask maybe a silly one. So as you were configuring it at the beginning of the session, I remember you were putting in a password. Is this something the Raspberry Pi actually comes with straight out of the box? It provides a password, or did you first have to set it up?
Yeah, so the one actual screenshot you saw out there for Debian version, and usually when it comes, it just gives you on the box what the password is. But if you're gonna do, in my case, I downloaded the Ubuntu, for example. When you install the Ubuntu, you kind of almost like a SA password, you kind of set that in the beginning. Yeah.
All right. Okay, sounds great. Well, thank you very much. Does anyone have any other questions? Okay, I think we're all set. Thank you. Really appreciate your time. Great session. I now know a little bit more about Raspberry Pi, but just a little. Not your fault, mine.
Yeah, no, I was like that.
It's a mystery. I struggle with the concept. Unfortunately, I think it's a little too much for me. But you did definitely shed some light.
Yeah,
Thank you. Really appreciate it.
No problem. Thank you for